Okay, here is the alternate series test web-assigned homework. So the first question is determine the convergence, right? Divergence of this, and you can see that it's an alternating series because it's that -1 to the n plus 1. So the two things that make an alternate series converge are that the limit of just a sub n, so that just means you can ignore the -1. So as n goes to infinity is 0, and that's obviously the case here. So that's a check. And then the a sub n plus first term has to be less than the a sub n term for all n. So in other words, every term is getting smaller. So the a sub n plus first term is 1 over n plus 1 plus 4. And the a sub n term is 1 over m. Oh, I'm sorry. I screwed that. A sub n plus 1 term is n plus 1 plus 4, which is n plus 5. Sorry. Just noticed that. And the a sub n term is just 1 over n plus 4. And obviously, since this denominator is bigger than this denominator, then that expression is always less. So that's the second thing that has to happen for a alternate series to converge. So this converges. Next problem is the same question. The limit as n goes to infinity of 1 over e to the n is 0. So there's the first condition for convergence. And 1 over e to the n plus 1, the n plus first term, is obviously less than 1 over e to the n because the denominator is bigger. So that was an easy one. Both of those are true, so it converges. So rolling along here. Here we have the limit of a sub n is not 0. So that, if you think about that, what that means, it means the last term is 8 over 7, and it doesn't really matter that it's going plus minus plus minus. It's not adding 0 to the end. So you can kind of think, well, this is nth term test. Since the last term is not 0, we really don't have to go any further. We know this diverges. So now we're really rolling along here. For this one, the limit as n goes to infinity of n over n squared plus 5 is definitely 0 because the degree of the bottom is bigger. The n plus first term will look like this. And the question is that less than the nth term, which is this? So now we have a couple things going on. We're adding 1 to the numerator on this one, which would actually make it bigger. However, we're also adding 1 to the denominator, and we're squaring it. So that means when you compare it here, this denominator is going to be growing quicker than the sum to this numerator. So this denominator, in essence, is going to be much bigger than this denominator, especially as n grows. So yes, this is less than this, and you can check that in the calculator if you'd like. It converges. So now we finally have a different question. It says, use the alternating series remainder theorem to determine the smallest number of terms to approximate the sum of this series with the error less than 0.0001. So the alternating series remainder theorem basically says that your sum is going to be within the first term that you omit. In other words, if we add 10 terms of this series up, it will be within the numerical amount of the 11th term, the first one we didn't use, within the actual sum. So if we want to get this within 0.001 of the actual sum, and we need to know how many terms do we have to actually add to, we need to know that our first term after what we're adding to is less than 0.001. So in other words, this is the last term that we will have, whatever, n equals 6. Our last term will be 1 over 6 to the 5th. That tells us what the approximate sum is. The error would be that first term we omitted, so the next term, which is the n plus first term. Hopefully that didn't sound like a great explanation to me. Hopefully it sounded better when you actually listen to it. But we need to figure out when this is less than 0.001. So I guess what I would do here is, on the calculator, I would reciprocate this. So that is 1,000. And now I would take the fifth root of both sides. So actually just raise that 1,000 to the 1/5. That's the quickest way. And then subtract 1, and that will give us the number of terms we need. And that is 2.981. So we need only 2.981 terms. So I guess you can't have 2.981. 2 is not going to be enough. So we'll have to call it 3. Hopefully that made sense. The next one. Okay, so number 6 is the same deal. We want to be within 0.0001. However, this is an exponential, so this might be a little bit different. So the n plus first term is the one that will give us the error. And we need to make sure that's less than 0.001. I'll do the same thing. I'll flip both sides. I'll divide by 2. And then I really don't know what to do to solve this other than take my calculator. I know n plus 1 factorial is not getting too big. So I'm going to trial and error this. If you can think of a better way, let me know. But so we have 1 times 2 times 3 times 4 times 5. I know that's not going to get it. 120. So 6 will be 7. Oops, 6 is 720 already. So I need this to be less than 500. So the answer would be this factorial would have to equal 5 to be less than 500. So now remember it's n plus 1, so n plus 1 equals 5. Therefore, n equals 4. So I'm going to stop right here because the next question is different. So I'll start a next video with that. As soon as I can find out how to shut this off. There we go.